Today we begin our journey into creating classes and really doing object-oriented programming. Now we've been doing object-oriented programming and using classes all along because in Windows Forms we've created a bunch of objects that are based on different classes such as labels and text boxes and buttons and timers and image list. Each one of those instances that we created is based on a class of that type of object. So there's a button class, there's a label class, and every time we drag a button onto our form, we're creating an instance of that button class, and then we're using properties to change the look and feel of that button or that text box or that label. Remember, we talked from the very beginning that classes have properties, methods, and events. So we've used properties in our code, such as if we have a text class named txt class A and we want to set the text to 145, we can do that in code. We're changing the text property. Same way in code, we can issue a method call. So LBL total revenue, if we want to clear the text of that label, we can issue the clear method. And then of course we've used events along the way as we've programmed and tied our interface to our code. So we might code for the BTN calculate revenue click event. We've also used some classes that are not visible but are simply in code. So we've used a math class that had some methods to it, including POW or POW for taking exponents. So in this case xyz equals math.pow 3, 2, xyz would equal 9 or 3 squared. We've also used the random class to create random numbers. And I want to point out this is sort of the way that we create new objects or new instances. We create an instance name. In this case I named it R&D, and again I could have named it Fred or John or Sally. I named it R&D and it's of type random. So when we create a class, that class is a data type. And as such, we can create a new instance of it using the new keyword. And this random with the parentheses is what's known as a constructor. So it tells the class to create a new instance. So we've been using classes all along. A class then is really nothing more than a programming paradigm using objects. And those objects contain data, which we might refer to as fields. Those fields are accessed by properties, and they include methods for interacting with that data or processing the data or manipulating it in some way. And it's really a class defines a data structure for us, and it becomes the building block for creating our applications. So while it defines the data structure, it also defines the type of operations that can be used on that data. So what we're going to get into now is creating our own custom classes. So we've been using classes that are provided for us out of the different APIs and so forth that come with C#. So what's the advantages of classes? Well, this modular paradigm of working with these objects makes it easier for team development on larger projects. Each person or each sub-team can be working on a particular object, particular class. Those classes are brought in. They're sort of like black boxes in that we don't just have to know how it all works inside. We just care that it works and that we can make calls to it. We can create instances of it. Classes also ensure uniformity. So we've seen that in creating Windows Form, every button has the same properties. Now we can change those properties to make different buttons look differently and maybe behave differently. Same thing with labels. Every label has a text property. Every label has a size property. It ensures uniformity when we're addressing those properties and working with those objects. As we make a program more modular, it becomes easier to debug and much easier to update, which in the long run saves us money or saves a development company money in terms of maintaining that software and even building that software to begin with. Classes are extensible and they're reusable. So I can define a class. Maybe I want to have a class for clients. And that class for clients would include their name, their mailing information, their email, things like that. And I might use that for somebody who's hired me to write a program for them. And then another person comes along, wants another program written. They also need information about clients as data to be stored. And I can simply pull that same class I wrote for client 1 and use it for client 2. The objects themselves, I mentioned, serve as data structures and makes it much easier for us to manipulate and work with that data. It also protects the data. And so one of the ways that it protects that data is something called encapsulation. That's one of the 4 pillars or principles of object-oriented programming. Encapsulation lets us hide the raw data and hide the inner workings of the class. We don't really care how a class reaches a result. We just care that it reaches the correct result. How it gets there is of no concern to us, only the person creating that class. And then we have inheritance. One class can take on the format of another class. We have a parent class and a child class. An example of this might be a banking account. So we have a banking account class as the parent, and that class may include the owner's name and their account number, but then there might be child classes. So we might have a child class for a savings account and a child class for a checking account, and those two are treated a little bit differently. Polymorphism allows us to invoke different methods for parent and children. Abstraction lets us represent features in a parent without details, but we provide the details in the child class. So I might, in our bank account parent class, create a method for end of the month routine. But in the checking account, that end of the month routine might charge a fee if their account is below a certain minimum amount. But in a savings account, the end of month routine, as it's implemented, might add interest to the account. There's another pillar or another important term here. I would probably argue it's a pillar, and that is overloading. It's the idea of having the same method but with different parameters. We're going to see that in constructors pretty quickly, but it allows for contextualized instantiation. So I can create a new instance of a class, and I can pass it some data to create that, but maybe in a different context I want to pass it different data to create that instance. That's called overloading. So we'll look more at each of those as we progress through the course. Let's take a look at how classes work with our main program. So a class is really nothing more than a blueprint. It's a blueprint for defining instances of an object. And that object, as we mentioned already, has properties, methods, and may have events. So we define that class as a separate, we can define that after our main class, or we can create it as a new class file. And if we create a new class file, it'll have a .cs extension on it. So let's say we create a file called comics.cs, and we'll do this in the next video. That class is going to have properties, it's going to have constructors, it's going to have methods. Now those properties will be things like I want to keep track of the comic character's first name, their last name, the name of the comic strip that they appeared in, what type of character is it? Are they a human? Are they a dog? Are they a cat? Are they an elephant? Whatever. Who is the cartoonist and what year did it first appear? Those are properties that are backed by fields of the class definition. Then we're going to have methods in our class that do something. So I might have a method called age. And the age method will return how old the character is based on the year they first appeared and today's date. So for example, Charlie Brown first appeared in 1950. Today is Sunday, March 17th, 2019. He would be 69 years old. Or we can display info that might provide a string of some information about that entity. So over in our main program, the way we interact with that is we'd create a collection of some sort to hold that data. Now that might be a database backend, that might be an array, it might be an array list, but we're going to create some type of collection to hold the data. So here we have an array of type comics. So again, this is my data type. My class is a data type. I'm going to name the array comic figures. It's going to equal a new comics, and I'm going to have 100 elements in that array. To populate the first one, I'm going to say comic figures sub-0 equals, and I'm going to call this new comics. This is a constructor. This defines a new instance of my comic class. I'm going to pass it some data. The data is going to be in the format of first name, comma last name, comma strip, comma type, comma cartoonist, comma year appeared. So Charlie Brown, Peanuts, Human, Charles Schulz, 1950. And it would create that instance of a comic object as part of my comic figures array. And I can do the same thing for other comics. Then if I wanted to call a method out of that class, I might have a label called LBL output. I'm going to set the text of that equal to comic figure sub-0, that's my Charlie Brown instance, dot display info is the method that I created in the class. And that method then returns a string, puts it in LBL output.text that says Charlie Brown, comma, drawn by Charles Schulz, comma, first appeared in Peanuts in 1950. So that is how classes work. We don't care how the display info came up with that string, whether you use string builder or use string concatenation. That doesn't matter to us. All that matters to us is we're calling it, and the black box of the comics class is returning a string that we put in our label.